Hey, ladies and gentlemen, welcome to 4.4 Rhombi and Square Notes. We're going to start with a rhombus. A rhombus, it's a parallelogram with four congruent sides. Okay, so if it's a parallelogram, it's going to hold true all those parallelogram properties or rules. Opposite sides are congruent and parallel. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect each other. Okay, so let's just draw those few things. Opposite sides are congruent and parallel. Okay, and in a rhombus, all the sides are congruent, not just the opposite sides. Okay, opposite angles are congruent, so we have these two here, and then these ones here that are congruent. And we have consecutive angles are supplementary, so like angle F and angle J, when we add them together, they add up to 180, and so on around our rhombus. And then diagonals are going to bisect each other. So if they go like this and like this, we create some bisected pieces. All right. So let's talk about a few other rules that hold true to rhombi. In a rhombus, the diagonals are perpendicular. Okay, so remember the upside down T sign is perpendicular. So what that means is that my diagonals meet at 90-degree angles. And then also in a rhombus, the diagonals bisect the opposite angle. So if we look here, angle 1 and angle 2 are congruent. But if we remember, angle P is congruent to angle R. So that means that angle 3 and angle 4 are also congruent with angle 1 and 2. So all four of those are congruent. Oh no, I'm going to run out of space. There we go. And then the same thing gets told for 5 and 6 with 7 and 8. Those are also all congruent. So angle 5 is congruent to angle 6, which is congruent to angle 7, which is congruent to angle 8. Okay, so let's go ahead and use this idea in these problems here. Okay, so the first one says if the measure of angle BCD. So BCD, which is this angle, is 64. So that whole angle C is 64. Find the measure of BAC. And so that's only half of this. All right, so we keep in mind that opposite angles are congruent. So that means this entire angle is 64. Now the diagonal bisects it. So we're going to take 64 and divide that by 2. So the angle BAC is equal to 32 degrees. It's half of that angle. All right, so I'm going to erase that just to clear up our picture. Oops, there we go. All right, so let's do the next one. AB is 2x plus 3. And BC is x plus 7. Find CD. So we're looking for this length. Well, before we can find that length, we need to determine what x is. In a rhombus, all of the sides are congruent. So 2x plus 3 equals x plus 7. Go ahead and we're going to subtract x to both sides. And I'm going to subtract 3 to both sides. 2x minus x gives me x. 7 minus 3 gives me 4. Now that's not the answer. I have to find CD. So I'm going to plug 4 back into either AB or BC. And I see that BC looks easier, so I'm going to plug it in there. So I find that CD, or all of my sides, are going to be worth 11. Okay, so then let's chat about squares. Squares are also a parallelogram, so it follows all those rules on the front side, but it has 4 congruent sides and 4 congruent angles. So those angles to be congruent are our 90-degree angles here. Okay, and then all 4 sides are the same. So really a square is a rhombus. because it has 4 congruent sides, but it's got 90-degree angles, so it stands straight up and down. The other thing then it means it holds true for all rhombi rules. Okay, so what that means is that my diagonals are still going to bisect each other, but they're also going to meet at a 90-degree angle. In a rhombus, they bisect my angles in the corners, and because these angles are all 90, I know that this is a 45-degree angle. And that holds true for all of my squares. Okay, so parallelograms. What has right angles? Well, we have rectangles. And what has congruent sides? Rhombi. And what has right angles and congruent sides? A square. Okay, so a square is like a perfect rectangle rhombi child. Okay, all right, so the diagonals of the rhombus intersect at point B. Given the following information, to find the measure value. Angle WZX. WZX is this angle here, is 39.5. And we want to find the angle ZYX, which is this big angle here. Okay, so all the angles in the corners of rhombi are not congruent, just the ones that are on the same side. So this is also 39.5, which means that that corner is 39.5 plus 39.5. So this whole angle is 79 degrees. Now, because this rhombi is a parallelogram, angle Z and angle Y are supplementary. So I can take 180 and minus 79, and we get 101 for angle ZYX. Okay, I'm going to erase that so that it's not clouding what we're doing for our next problem. All right, WX is 8x minus 5, and WZ is 6x plus 3. All right, it's a rhombi, so the sides are congruent, and here it just asks us to find x. So we're going to set these two equal to each other and solve for x. So I'm going to subtract 6x to both sides, and I'm going to add 5 to both sides. So 3 plus 5 gives me 8, and 8 minus 6 gives me a 2x. So x is equal to 4. All right, let's look at this square one. This is a square, and WT is 3, they tell us. Ooh, got excited there, moved around. There we go. WT is 3. So we have to find all these other things here. So YW, WY. Okay, well that's this whole diagonal here. So if half of it is 3, the whole thing is 6. Now they're asking us for TZ, which is this down here. Well, the diagonals are congruent and bisected in this, so this is also 3. All right, next it asks us to find the angle WTZ. W to T to Z is this angle here. Well, what did we say that how the diagonals bisected in, or I mean not bisected, how did the diagonals intersect in a square? Well, they intersect at right angles, so this is a 90 degrees. And then we have the measure of WYX. So W to Y to X is this one. Well, if the angle in the corner for Y is 90 and the diagonal bisects it, this is a 45-degree angle. Now, let me just remind you, if I wanted to find out what YZ was, okay, so if I'm looking for this measure here, I'm going to look at this right triangle. I have 2 of the side measures, and I'm looking for the hypotenuse because it's across from the 90 degrees. So this would be a Pythagorean theorem. 3 squared plus 3 squared equals x squared. So 9 plus 9 equals x squared. So you can take the square root of 18 and get 4.2. Okay, so don't forget that we're dealing with right triangles here, so we can use Pythagorean theorem. All right, ladies and gentlemen, that's what I have for you. I will be checking your notes tomorrow. So please make sure that you wrote all the things down and that know that I'm going to be doing a notes check. Thanks. Bye.